Okay, guys, so we are going to be going over the review sheet so that you guys have the correct answers to study for the exam. So the first section here talks about molar mass. Remember, now when you're dealing with molar mass, you're taking the atomic mass of each element times by the quantity you have and then adding them all together for a total mass, okay? So for the first one, you're going to add sodium and bromine together, okay, equally, and you should end up with 102.89, and your unit is always grams per mole, okay? Now the next one, you're going to add 1 lead plus 1 sulfur and 4 oxygens together. So that's going to give you a mass of 303.26, okay? Next is calcium. You're going to take calcium plus, and remember when you have a 2 outside the parentheses, you distribute that to both elements. So it would be 2 oxygens and 2 hydrogens. And when you add them up, it's 74.12. Okay, now the next one is sodium phosphate. 3 sodiums, 1 phosphorus, and 4 oxygens should be 163.94. Okay, the next one is sodium carbonate. So you have 2 nitrogens, 8 hydrogens, 1 carbon, and 3 oxygens. And they all add together to make 96.11. And lastly, we have glucose, which is C6, 6 carbons, 12 hydrogens, and 6 oxygens, which comes to 180.18 grams per mole. Okay, so there you're just adding up all the atomic masses together to get a total atomic mass value. Um, all right, so next you're going to be doing the percent composition. Now, this is the same thing as the one above in terms of you're going to find the molar mass of the entire compound. Then you're going to take the mass of each element divided by the total times by 100, and your percentage should always add up to 100%. Okay, so for the first one, for the percent of hydrogen, you should end up getting 2.06%. Okay, for sulfur, okay, you should end up getting 32.7%. And for oxygen, you should end up with 65.3%. Okay, all right, so do that math. Remember, you're going to take each individual mass divided by the total times by 100. Okay, so now part B, you're going to do the same thing. So percent of carbon is going to equal 10.05%. Okay, hydrogen is going to be 0.85%, and chlorine is going to be 89.1%. Okay, all right, now we're going to do the next one, and that's a big one. So you're going to have percent of carbon is going to be 59.97%. Percent of hydrogen is 7.2%. Nitrogen is going to be 10%. And oxygen is going to be 22.8%. Okay? Then you have your percent of copper for the next one. That's 39.8%. Sulfur is going to be 20.1%. And oxygen is going to be 40.1%. So percent of carbon is going to be 42.1%. Hydrogen is going to be 6.49%. And oxygen is going to be 51.4%. Okay? All right. And then last one, sodium chloride, you're going to have sodium. Percent of sodium is going to be 39.3%. And for chlorine, it's going to be 60.7%. Okay? Number of moles. So this one, now in this bottom one, we're going to be calculating the number of moles. And remember, when you're going from grams to moles, you are going to divide by the molar mass. So you're going to have to add up the molar mass of your compound and you set up your formula as 1 mole is equivalent to the molar mass of that compound, okay, which is in grams. So you add up all of ammonium sulfate to get 132.16, and that's going to give you a 0.205 moles for your answer, okay? So you'll take your 3.3 times 1 over the molar mass, okay? Now flip your page over, And we're going to do some more problems. So this next one, we're going from moles to mass here. So remember, anytime we're dealing with mass, you're going to have to add up the molar mass of the compound. So for this particular problem, you're going to take what you were given, the 2.56 times 10 to the negative 4, and you are going to put 1 mole on the bottom, and you're going to multiply that by the molar mass of Fe2O3. And you should end up with 0.041 grams. Okay? Now the next one, you're going to take moles of O2 and go to grams of O2. Okay? And that's going to be 32 grams. Okay, remember, when you're going from moles to grams, you're going to multiply by the molar mass, and 1 mole will be on the bottom. So you're going to take 3.75 times 32, and you're going to get 120 grams. Okay? Next, you're going to take 15 grams. Okay, so now we're going from grams to moles again. So we're going back to moles. So that's going to be 1 mole here, and then we're going to do the molar mass of CO2. And we're going to take, that's going to be 44 grams there. So 15 divided by 44 is going to give you 0.34 moles of CO2. Okay. Now number 7, we're going back to moles again. So you're going to take the grams and you're going to put 1 mole at top and then 2.02 grams on the bottom, which is going to give you 309 moles. Okay, now this next one's a little tricky. So we have to get, it says molecules, not moles. So in this one, it's a 2-step problem. We have to go from grams to moles, which we just did in number 7, and then we have to go from moles to particles. Okay, so this is going to involve the constant. So here you're going to say 5.23 grams, okay, divided by, okay, 1 mole, and it's going to be 40 grams here because that's the molar mass of NaOH, and then you're going to multiply that by 6.02 times 10 to the 23rd over 1 mole. So you're going to take 5.23 divided by 40, which is going to give you 0.13 moles, and then you're going to take the 0.13 moles and you're going to times it by the constant so that you end up with 1.88 times 10 to the 24 molecules. Okay? Now, the next one, okay, we're going to go and do a basic one again where you go from moles to grams. So once again, we have to calculate the molar mass of copper phosphate, okay, which is 380.57 times 0.0786, and it's going to give you 29.9 grams. Okay? And then you have 4.18 grams, and we're going to moles. So we have to divide by the molar mass of lithium sulfite, and then you're going to times by the constant to get to molecules. Okay? And you should end up with 2.8 times 10 to the 22nd molecules. Okay? And the last one is 41.8 moles. And we're going directly to molecules. So we're going to times by the constant again. And that's going to give us 2.52 times 10 to the 25th molecules. Okay? So now we're done with that sheet. Okay? We need to grab our other sheet. Okay? And these are some word problems. So word problems are a little scary, right? Because a lot of people don't like those because they're a little bit scary. Now, the number 12 is going to be exactly like what we did in the lab the other day, right? So a chemist determines that 1.6 grams of iron reacts with 0.5 grams of oxygen to form rust. What is the percent of each element in the new compound? Well, first of all, you're going to need to have what? The total mass, right? So the total mass is going to be 1.80 grams, okay, when you add them together. So now for my iron, I'm going to take 1.26 divided by 1.8 times by 100, and that's going to give me 70% of iron. And then I'm going to take my 0.54 grams of oxygen divided by the 1.80 times by 100, and that's going to give me 30% of oxygen. Okay? All right, so now let's do a little bit of dimension analysis. You're throwing a pizza party for 15 people and figure that each person will eat 4 slices. You call up the pizza place and then learn that each pizza will cost you $14.78 and it will be cut into 12 slices. How much is the pizza going to cost you? You only have $70. Will you have enough money? Okay, so you have 15 people, right? And you know that you get 4 slices, right? Okay, for each person, okay? And that one pizza has 12 slices. And then the pizza costs $14.78 for one pizza, right? So the total cost is going to be $73. Do you have enough money? No. Okay, so not enough money. Better get some more money. All right. Now, in my chemistry class, you have 28 students who are each given 3 pens. If there are 8 pens in one package priced at $1.88 per package, what is the total cost of giving away pens? Okay, so you have 28 students, right? Okay, and 3 pens per one student, okay? And one package is 8 pens, and each package costs $1.88. So that's going to cost you $19.74. Okay, so you better bring $20. All right, now you find 13,406 and 190 pennies. How many dollars did you actually find? Each penny weighs 4 grams. How much did all that loot weigh in pounds? So it's 2 problems here. So first of all, we're going to take our 13 million pennies over 1, okay? And $1 is 100 pennies. And and that's going to equal $134,061.91. Okay. Now, how much did that loot weigh? All right. Okay. Do you even know what the word loot means? That's an old term. Since we're old people, that's an old term. Okay. All right. So these are all my conversions. Okay. 4 grams per penny, 1 kilogram is 1,000 grams, and then 2.2 pounds in 1 kilogram. So that's going to equal 117,974.472 pounds. There you go. Okay, and last one, convert 54 milliliters to liters. So there's 54 milliliters, there's 1,000 milliliters in 1 liter. So that is going to give you 0.054 liters. Okay, all right, good deal. So study the review. Oh, whoops, I forgot. Sorry, I almost forgot the matching. My bad. Okay. All right, so I'm just going to give you the matching terms so you can check your answer. 17 should have been E. 18 is H. 19 is G. 20 is A. 21 is D. B. C. And F. Okay? All right. So I hope you guys study well. Test is on Tuesday. Okay?